All right, in this video, I'm going to do a quick demo of how to do a Z confidence interval using just Desmos. So we have a problem over here, a random sample of n equal 50 drawn from a population sample mean of X bar equal 24. The population standard deviation is known to be 3.45. So we don't have any context to this problem, but we have all of the values that we need for a confidence interval. We're asked first, what is the appropriate distribution to use to construct a confidence interval of the true population mean? And for that, we have to consider the sample size and possibly the underlying population. We don't know what the distribution of the underlying population is, but we know that we have a large sample, n equals 50, and we're given the population standard deviation. That's our sigma. And so that means that we can do a Z confidence interval. So the distribution for the confidence interval is the normal distribution. Now we're going to construct a 98% confidence interval for the true population mean. Going over here to my Desmos graph, I'm going to access the inference tools in Desmos. And I can do that a couple of ways. I can type the word inference, and that will open the inference tools menu. Or I can go up here to the plus add menu and add inference, and that also opens up the inference tools. Now we're interested in a confidence interval here, a Z confidence interval, but we're going to select over here the Z test because all of the choices over here are given in terms of the hypothesis test. So we're going to select the Z test, and then we have the option to either enter raw data, which we don't have in this question, or we can click on the tab up here and go to stats. That's what we want here because we're given the statistics from our sample. So we know that the sample size that's given n equals 50. We're going to enter that. The sample mean is given as X bar equals 24. So that's going to go into the spot for the sample mean. And then we're asked for the population standard deviation. We were told that that is known to be 3.45. So those are the values Desmos needs in order to construct our confidence interval. We're going to click create test. And again, it gives us both options here, confidence interval and significance test. But in this problem, we're only concerned with the confidence interval. So we're going to use the confidence interval dropdown. I do just want to point out that you could also type in the syntax. If you're familiar enough with the z-test command, you would just type in z-test parenthesis in x bar and sigma inside the z-test function. So I'm going to drop down the confidence interval here, which is currently giving me a 95% confidence interval. That's always the default. And so it gives me the lower bound and the upper bound. And this visual here is just showing me that the center of the confidence interval, of course, is always the point estimate. And so for a confidence interval for the mean, the point estimate is X bar. And so the middle of my confidence interval is 24, my X bar. But I don't want a 95% confidence interval. I am asked over here for a 98% confidence interval. So I'm going to put in 0.98. So we put our confidence level in as a decimal, and now it's changed my lower and upper bound to correspond to a 98% confidence interval. The point estimate is the same because the center of the confidence interval is always that sample mean X bar, but it gives me my lower and upper bound, which I can just read from here. Now, if I need more decimal places for those, or if I need the standard error of my confidence interval, I can click the three-dot menu and all of that is given here. And if I want to drop these values down, like if I want to drop the lower bound down into a line or the upper bound, I can just click on that little export icon. You can see here, it also shows me the syntax for those values. And so it also gave my test the name T1. But if I needed to use these values in some other computation or something like that, then I would have them here. I could give them their own variable name, but I only need one decimal place. So I'm going to go over here and round my values to one decimal place. So 22.9 is my lower bound. My upper bound is one decimal place is 25.1. And it's also asking me to select the parameter that goes in the middle of my inequality notation for my confidence interval. The parameter in the middle is the population parameter that we're estimating. And in this case, since it's a confidence interval for the mean, that means the population parameter is mu.